Squeak, Rat of all trades here, and I'm about to do some more maze running Sudoku style with Marty Sears. He's got several rat runs out already. The first I didn't record, I just did on my own, and then I recorded the second. Here's number 3, which actually was released at least a week ago. At least on Cracking the Cryptic, it might have been released earlier. But I was at a music festival for the whole weekend. This was released right before I left, so like, I don't know, my paws are still dirty because I was outside all day. Anyway, I'm catching up. I know 3 and 4 are now out on Cracking the Cryptic, but here's 3. Normal Sudoku rules apply. Aim of experiment. Ditman the rat must reach the cheese by finding a path through the maze. This is the exact same. A lot of this is going to be the exact same as the other two. But each of these puzzles has its own twist. The path will be a sneaking line that passes through the centers of the cells without visiting any cell more than once, or crossing itself, or passing through any of the thick maze walls, which you probably saw there. They were all yellow. Okay. So the special constraints here is there are black currants. I don't think I've heard them called that before, but I've heard the black crop key dots, where the 2 digits on either side have to have a 1-to-2 ratio. I've used those before. And test constraint, the correct path will be a valid Dutch whisper line, which means that adjacent cells along the path must have a difference of at least 4. Okay, so that's not the German whisper line. I might have done that for a second, which is a difference of at least 5. Anyway, difference of at least 4. Let's start. Let's see. The second puzzle I got finished in just about an hour, but there were like 3 times I got caught up on the same thing that I did. I didn't do anything wrong. I did something ungood. Double plus. Something like that. But yeah, anyway. So, yeah. We are going to have to find some sort of path to the cheese. There we go. Nope, that's probably not it. But, Dutch Whispers means that we could have any of our digits involved, actually. But what I'm noticing is the crop keys, or the black currants. So, let me actually, where's my mouse? There it is. Okay. So these 2 cells have to have a difference or a ratio of 1-to-2. I used these in my own rat maze in the very first ones I was making. And there's only a few possibilities here. We can have... Oh, come on. I can't see my mouse today. We can have 1 and 2. We can have 2 and 4. We can have 3 and 6. And we can have 4 and 8. Those are the only possibilities. And this possibility is our only possibility in which we could pass through. So that means... Okay, first of all, he's got to get through here or through here. And then he's got to get through one of these 3. So one of these 2 has to be 4-8. Has to be a 4-8 pair. One of those has to be a 4-8 pair. One of those. Well, if this, then it's both. Okay. Can't be this way. All right. If the rat goes this way to get through, that means all 4 of these have to be either a 4 or an 8. And 3 of them are in the same cell. So those are not on the path. Okay. That means what is on the path? It means these 2 are on the path, and they are going to be 4, 8. What color should I do? I'll do green for the path. I still don't know if it goes that way or that way. And then I don't know if it goes that way or what. This is interesting. Because we could go here and then diagonal. And then cut back. Yeah, I feel like this one's going to be quite a bit harder. And the last one took me an hour. So let's hope I don't make any big mistakes. Okay, these can't be 4 and 8. So this could still be part of the path if it goes down there. But let's do red. So those can't be part of the path. These can't be part of the path. If these are 4, 8, then those can't be 4, 8. Yeah, okay. And then can't go that way. Has to be that way. Okay. Okay, we're making progress already. That's good. And then it can't be those 2. Okay, so 4, 8 has to be there. Great. So we have 1, 2, 3, 4, 5, 6, 7 in a row. That's important. Now what? 4 and 8 have to be here, just doing some Sudoku. So I'm going to get rid of most of these. Because I already know it's here. Okay. Let's say this is 4. I can think of 2 ways of going on. One is trying to figure out the numbers on the path, and the other way is figuring out the crop key dots. I'm not sure which is the answer, or maybe it's something entirely different, but those are my 2 ideas. So if we start with this idea, figuring out these numbers, let's say this is a 4. That is much more constrictive than if this is an 8. If this is a 4, this must be a 9. Let's just put some in. Basically, we're going to have to go high, low, high, low, high, low, high, low. And the interesting thing about Dutch whispers, so for German whispers, it's always going to be alternating, high, low, high, low, high, low, high, low. For Dutch whispers, you could have a 1, 5, 9, which means you have a low, medium, high. And then it switches. However, we can't have a 9 here. We could have 9, 1, 5 here. Okay. Oh, actually, let me do those 2. So this is low, low, low. Okay, so we would have to have a 1, 5, 9 somewhere. And I think that's true even if we change it to be 8, 4. Yeah, because these are 7 cells apart. So they should be the same parity, or they should be the same highness or lowness, but they're not. So we do need 159 somewhere. Okay, still don't know what to do with that. I know I don't think this is the right thing to do, but I'm going to keep doing it. We know there has to be a 159 somewhere. So that could go here. Oh no, because this can't be a 5. If you remember down here, these are our only options for the crop key dots. So we could go low, Oh, yep, yeah, this is impossible. Yep. 4, 9, and then we can't get a 951. Okay, so we know. Sorry, I'll explain that clearly. So we need to get the 951 in here in order to change the lows and highs, because otherwise these two squares and those would all have to be either lows or all highs. But here, this is along the path, so it needs to be 4 away at least. It can't be 8, because 8's right here. And if it's 9, that means we have to do our 951 right now, and we can't, because we'd get a 5 here, and there's nothing that is a 1 to 2 relationship ratio with 5. So we can put these in, and we can delete that. Okay. Now, this must be a 9, because it can't be an 8. And then we have a 5, 1. Great. Okay, so here's the other thing I can do. That's going to stay the same color. These are all high. I'm going to make them light or dark? I think light. That's like a topographical map. Those ones are going to be dark. So high, low, high, medium, low, high. Oops, this should be high. Okay. Is it possible? No, we'd need a full 3 spaces in order to do another 159. So this is going to continue low, high. Oh, sorry, high, low. I know what I said, that the darker color would match a low topography, but for whatever reason, it just feels like it's darker, so it's fuller to me, so I think it should have a higher number. I don't know. I'm going to try to continue it this way, and hopefully I don't make any double plus ungoods or whatever. Okay, so the highs can only be 6, 7, 8, or 9. This can't be 8 or 9. This could be 9. All right. And then this is a 2, 3 pair. Okay. Let me put this a bit closer to me. And that can be 1, 2, or 3. Now what? If this goes down, it has to be a 9. And that can't be part of a crop key. So if it goes up, actually it could be an 8, weirdly. It could be an 8 or a 9. If it's a 9, then we don't have a 5, 1, because there's a 5 there. That is high up on the mountain, light square. And actually, we don't know for sure that this isn't part of the... I was about to turn this red. We don't know for sure it isn't part of the path, because it could go back around and still use that square. Uh-huh. So this is definitely dark. Definitely light. Definitely dark. We can't have 951 in there. We could have 1 on one of those. Here's another high. Oops. All right, so this is another 6, 7 pair. If this is 6, then it has to be 1 and 2. Because 3 is only 3 away. Okay, got one more high. And we could have a 951 here. So now I can't continue. I'll just make it a regular green for now. We can't go this way. Okay, so we will have to go here, and then one of these directions, and then here, and then here, and then there. Okay. Don't know if it's down or up yet. And then this still has a bunch of options. Okay. Can't go there. Let's see if it stays high, low, high, low, high, low, high, low, high, low. I mean, I don't see why that can't work. Well, one thing to note is that 6 of these crop key numbers are low. 2 of them are high. So it is more likely that these crop key dots will be low, I think. If we continue with the high-low, that gives us a high here, which gives us, we can't have 8, so it would have to be 6-3. Is that possible? Let's check it. 6-3. This could be a low 1 or 2. I don't immediately see anything wrong with that. Okay. Oops. Four and 8 have to be in this box. It's kind of hard to see the 9 boxes, but I have been looking at those. 4 and 8 could be here, so they're just on the path anyway, even though there's not a dot there. Or they could be here. They can't be here and here or here and here. All right. Wait, they could be here or here. Okay. Also, it could be there. Well, no, sorry. If the path goes up, then they can't. Okay. I feel like double checking the rules real quick. I know the aim of the experiment. Things may move diagonally in spaces like these, but there aren't too many of those spaces. Not all black crots are given as important. If there was a negative constraint, then that would mean, for instance, this cell could not be 2, because then this would have a ratio of 1 to 2. But it's saying that not all of these are given, so we're allowed to make more 1 to 2 ratios than it shows us. All right, well, there's going to be a 5 on one of those 2 in this row, and it can't be on the correct, so that's there. And there's a 5 on one of these 2. Again, it can't be on the crop key. I'm going to keep switching my words for those. Crop key. Two, 3, 6, 7. I might as well finish that. Yeah, and then 6, 7, 8, 9. It can only be 6 or 8. And if it's 8, so, okay. So I just said the 5 couldn't go on a crop key. So the other idea that's important here is that 7s and 9s also can't go on crop key. We can look at those numbers in the bottom left again on my grid. So this can't be, we've got a 1, 2, 3 pair. This can't be 1, 2, 3. It can't be 4. It can't be 5. So the only other options are 6 and 8. If it's 8, then this must be 4. It can't be 4. So this has to be 6 and 3. Okay, that is giving us some numbers there. This can't be 6 or 7. That's 9. That's 8. That doesn't do much after that, but that was a good start. So 6 must be up here. And then it must be in this row. So that is a 6, 3. Okay. Right now, this one's feeling easier, but we'll see about the ungood things happening. If that happens. This is 4, 5, 7. Only option here is 4. Okay. And this is a 5, 7 pair. Because again, the crop key. 5 and 7 can't go on. And then 4 can be in a 1 to 2 ratio 2 different ways. It could be 8, except there's an 8 there and an 8 there. The other option is a 2 and a 4 instead of 4 and 8. So we can do a 2 and 4. And we are almost done with the top third of the grid. Where's my mouse again? Okay, I'm going to use my keyboard. There's my mouse. And 1, 9. Okay. You know what? Oh, I didn't mean to do that. I was just trying to show where in this box the green isn't actually on the path. I'm going to make it red, but it's still light. So I was still coloring the upper numbers and the lower numbers, or digits rather. 3 can't be there, so we start on a 3. Okay. Now what? This can't be 4, 8, because the 4, 8. It can't be a 2, 4 pair, because this 4 is in the same box. It can't be a 3, 6 pair because of that. So the only other option is a 1, 2 pair. And that will give us a 2 here, because of the 1 there, and 1 here. So this is dark. I was about to say light. I know it's not. Okay, and we do need a 9, 5, 1 in here. How can we fit a 9, 5, 1? Well, and we need a 9, 5, 1 because otherwise this is dark, this is dark, this is dark, this is dark, but we already know that's not dark. Okay. I think the 4, 8 is going to help us. We could have a 4, 8 like something like here. And then that gives us room here for now. Sorry. I've got an idea, but I'm figuring out how to say it. So we need a 9, 5, 1 somewhere. And if the path goes down like that, I think it is more constricted than if it goes up like that. Because we know we need a 4, 8 in these. The least constricted would probably be if 4, 8 are here, so we don't have to worry about them when we're doing this. Although we also might need a 4 and an 8. I'm not sure. Okay, anyway. Let's go with a 9, 5, 1. If I do 9 here, 5's in the column, so I can't do a 5 there or there. Okay, so I could do a high here. Basically, the 9, 5, 1 can either start on the 9 or it can start on the 1. So we can't start on a 9 here, but we can have that be a light square. And then one of these be a dark, which would be a 1. 1, 5, 9, or 1, 5, 9 still get blocked by that 9. So that doesn't work. So one of these is definitely dark. I'll put one of them's on the path, one of them isn't. And then a light one again. Okay. Nine, 5, 1. We still can't do a 9 on either of those. So we keep going. Can we put a 1 on this low square? Yes, we can, and that is our only option, 159, right there. Okay. 9, 5, 1. What? Wait. Whoa. Oh, yeah. I didn't even see that one. So, yeah, we have another option, though. I said it was our only option, but it wasn't. So we got dark here, we got low. Let's put our 9 here. Here is our high 9. And here is our medium 5. Why did I say it could only be 6, 7, 9? Because I think I thought it had to be a high square. We can put 1, 5, 9 here. All right, that tripped me up. So that was something I missed. Okay, then low, then high, then low, then high. I don't know which direction it goes. Can we figure it out? We do know. Okay, all the light squares are there, and then this will be a dark square. Okay. So 1, 2, 3, and 4. This can't be 1, 2, or 3. This must be a 4. All right. These are both, or these are neither 2, so 2 must be there. Oh, there's a 3 there. Okay, 1 and 3. All right, and then 6, 7, 8 here. 7, 6, 8. And now let's see. We can go down this way. Okay, I thought it was going to go up. But the path does not go up because that would be 4 to 6, which is only 2 digits apart. Okay, so those are not on the path. These are on the path. Right. All right. Next, this cannot be a 5. It has to be a high digit. Okay. Can't be. Well, it can be 6, 7, or 9. We got lots of options still. Okay. All right. Here, let's put a 3 there because of Sudoku. So 5, 6, 7, 9 here. 9 goes there, so 9 must be here. 5, 6. Oh, sorry. I thought this was a box for a moment, and thought, oh, this must be 7. Oh, there's 2 8s, so it could also be a 5. But anyway, this still has to be 7 because of this box. The only options in the box are 5, 6, 7, 9. We have 5, 6, and 9. So we get 7. All right, then 5, 6, 9. Okay. If this is a 9, I mean, it's fine. This is interesting. If this is a 9, then it's fine for a 9 to be on the path without being part of a 951. We've got that happening here. It's just a regular high note. Not a note, a regular high value. But here, if we tried to make a 951, it wouldn't work, I believe. 951, we've got a 1 there. Or 9, 5. This 9 would actually make this a 5, and that would make this a 6. but we couldn't have a 1 here or here. And if this is a 9, then our path can't go left, because then we'd need a 1 in one of those. And we know that's not true. So if we can prove that the path doesn't go this way, then we can prove this is not 9. Okay, so if that's, let's say it is 9 and then try to disprove it. Oops. Let's say it is 9. We already proved it can't be 5. If it's a low number, it has to be 3 because there's 1, 2, and 4 in the column. So we have to be a high number. It could be 8 or 9. What's left in this column? 8, 9, 4. Right. 8, 9, 4. If this is 9, it can't be in the crop key, so it has to be 8. No, we're still not done. So I just proved that it couldn't go straight down. Because if this is 8, then this is... No, I still proved it. Okay, sorry. This cannot be 4. I was thinking if it can be 4, then that means 4 can't be here. But anyway, this cannot be 8 or 9. So let's just back up a little bit. So this has to be 6. And, oh. You have to go this way now. Wait. What happened? I'm going to do the check. I'm going to do the check, which says something's wrong. Everything here is correct. Hang on. Everything here is correct. Good. 6. Then I would need a low. 6 couldn't go to 3. That's too close. Okay, so it has to be a 9. Hang on. 9. 3. So the 9 is correct, but the 3 isn't. Hang on. I'm just checking. Have I missed any other paths? Because I thought I just proved that the path can't go here, and that it can't go here. So I thought it proved it can't be a 9. But then I proved it can't be a 6. So that's a problem. All of these numbers are correct. We know we can't go this way because this is only 3. Difference of 3. That's a difference of 1. That's a difference of 1. That's a difference of 1. I mean, this we could try to keep going, but then we'd need a 4, 8 here. Mm-hmm. Well, we know from the check that it's supposed to be 9. But let's go through it carefully. Let's say this is 6. 6. Then, it has to be part of the path. I was just looking when I was doing this is a difference of 1, this is a difference of 1. I was figuring out if there's any other paths that could be taken here. Here, the 6 can't go left, so it must go down. But it would need to go to a 2 or a 1. And it's got a 2 or 1 here, which means it can't have a 2 or 1 here, or a 2 or 1 here. Okay. We've proven it's not 6. And we've also used the check function to prove it's not 6. However... Aha! Got it. Let's once again prove this can't happen before I show you what does happen. So 5, we can put a 5 and 7 up there now. So in this column, let's just write all these columns in, actually. I think that'll be useful. 1, 5, 8, 2, 4, 9, 3, 6, 7, 4, 8, 9, yeah. One, 2, 5. And then 3, 6, 7? Yeah. I like what I just did here, because I'm going to ignore the paths for a moment and just do crop key Sudoku, which is 7 can't go there. It must be there. Here, 9 can't be part of the crop key. 8 would need a 4, so it must be 4 here. And that must be 2 here. Okay. 9. So we can't go this way because this is high, and then we would need a low. We can't do a 5. This is another low. So we can't go this way. So we have to go this way. And, yeah, we can't have a 1 here. We can't have a 9. That's what we can do. We can go back to 9 because this is in a different box than that. Very good. Then we could have a 5 and a 1. Who knows? This cannot be an 8, but that's the only thing it can't be. All right. We also know that this cake has to be high now. It's either 8 or 9. It could be a 9, 5, 1, 8. Our path could go like this. I was just going to say, a few minutes ago, when I thought that we had figured out the path and it had to go to the bottom right, when it had to go this way, I was going to say, ooh, this is interesting. This is a first. Because we're not using quite a lot of the grid for the path. And usually our rat here likes to explore pretty much as many nooks and crannies as he can before he gets to the end. But that's not what's happening here. But anyway, actually it is going to be what's happening here. Let's see, we can't go like that, because we'd use that twice. So these two cannot be part of it. Anyway. 1. Sorry, I was just doing these. Let's do the same thing for the rows. This can be 2 and 9. 5, 6, 8. But yeah, if this had happened, then that would have been interesting, and then we would have just used regular Sudoku for the rest of the grid, and not been able to use the path at all for the rest of the grid. 5, 6, 8. Well, I said I was going to do this. 1, 4, 7. Well, okay, so these can both be 1, 4. 7 cannot be here. 7 cannot be part of that, so 7 must be here. Seven must be in one of these. I'll leave that for now. This cannot be a 3, 6 pair. It's a 1, 2, 4, 8. Let's see. This cannot be a 1 because that would be a 2, and we have a 2. So this has to be a 4, and it still can't be a 2. It has to be a 4, 8 pair. Five, 8, 1, 1, 9. All right, I am going to finish this puzzle quicker than the other one. It was just over an hour, just over for the other one, and I don't want that to happen again. I could do this in 45 minutes. Yeah, that will be the goal. 2, 4, 5 here. 2, 4 have to be there. I wonder if some of these crop keys are unnecessary. Like this one, it's not necessary for figuring out this column because we have a 4 and 2 there. Was it necessary for figuring out the path? I can't remember. 1, 3, 6. Oh, yes, because we couldn't go that way. Okay. That was like the very first thing. Okay. Oh, we got a 1 here. So we got dark. We could still have... No, we can't have... Because the 9's going to be over here. So we can't have a 1, 5, 9 here. But we could go diagonal. The reason I'm saying that is because if we look at a section that doesn't have any 1, 5, 9s, that is all a checkerboard pattern, dark, light, dark, light. The 1, 5, 9 can change that, where now 2 darks are next to each other. And a diagonal can also do that. Okay. I think we need to figure out the path now. All right. Let's say there are no diagonals and no 1, 5, 9s. What happens? Light, dark, light, dark, light, dark, light, dark. Okay. So the amount of 1, 5, 9s and the amount of diagonals we have has got to be odd. If we do 1, that will get us to the right spot. If we do 2, that's just going to undo itself. So we'd need a dark here. So what options are there? There's 1, 5, 9 here. What I'm hoping, this would be really cool, is if there are 3 of them. There is just enough space to put 3. We've got a diagonal there, and then like a 1, 5, 9 here. Or 1, 5, or 9, 5, 1. 1, 5, 9. Yeah, okay. 5 can't go to 2. So yeah, we can't do this diagonal. Okay. I've got 3 minutes. Let's do something. 1. If it goes there, then it has to be 6. Then it has to be 1. Let's just try something. 6, 1. Can't be 5 because then we'd need a 1 or a 9. 8, 2 or 4 both work. 2, 7, 3, 8. That would work. I know I can figure this out quickly, but I'm wondering if there's a clever way to do it instead of just trying one. because I'm thinking just let's assume this is correct. Well, an 8, 9. Let's just put one of those in and see what happens. That'd be 8, 5. Oh, we know these all have to... Okay. Maybe I know a clever way. And this is going to make it so I don't finish in 45 minutes, I think. But these have to be part of it. This has to be part of it. This one must be dark, not light. This one must be 8. Okay. Maybe I can still do it. So this must be part of the path. And it must be dark because it can only be a 2 or a 4. Then we can't go there. So this is light. This is dark. Oops. This is light. Okay, one goes to there. Yeah, there isn't anywhere else, any other way to get... We don't have any 5s here, so this has to go straight there. 6, 1, 8. Okay. Oh, that could be a 6 and a 3. Okay, we can't go there, so it has to be 1, 5, 9 here. Okay, we are going to use 3. We're going to use that, and this goes to there. So this must be a 2. Okay. I'm not looking at the time. Well, now I'm looking at the time, and we did it. Let me draw the path. There's got to be a quicker way to do this. And then here. Yeah! 12 seconds left. Experiments completed successfully. Cells visited. 39. 39. Blackcurrants eaten 3. The transition to full-size maze appears to have had no negative effect on Finks's performance whatsoever. She showed high levels of self-control, rejecting the blackcurrants that would have been detrimental to her overall goal, whilst enjoying those that happened to lay on the correct path. Interesting. Yeah, I know I kept saying he because I was kind of thinking about me and also kind of thinking about another rat I know called Think. But I do happen to know that Finks is a she. So, I introduced this puzzle by saying Ditman. Ditman is doing the maze, so I don't know. I'll have to decide who is doing the maze next. But there we have it. It goes like that. And we have 3. That's... Oh, I see. I had the wrong colors. But, that still works. All right. Do I have anything to say before you go? If you happen to watch this far, I'm going to keep doing this series of puzzles, and I'm probably going to share my own puzzles sometime. I'm the rat of all trades. I do a whole bunch of different things, and I'm late on quite a few things that I'm going to be working on this week. And I actually suspect I'm going to be releasing quite a bit of random stuff this week. Okay, that's it. Squeak you later.